Hi, this is Hilal. In this video on mathematical economics series, we will learn about the inverse matrices. Now, an inverse which is denoted by this symbol a to the power minus 1 can be found only for a square non-singular matrix A is a unique matrix satisfying the relationship which I will give here. Now, first of all, square matrix can be found only for a square matrix. By square matrix, we mean the number of rows are equal to the number of columns. That is, if I have a matrix like this 1, 2, 4, 3, this is a square matrix of order 2, which is denoted by 2 by 2. Now we can find inverse for only for a square matrix, and another example could be 1, 4, 3, 2, 6, 1, 1, 0. Let us say it is 2. Now this is also a square matrix of order 3 by 3. So we can find an inverse only for a square matrix. That is, the square matrix should be also non-singular matrix. The matrix should be also the non-singular. By non-singular, we mean that the determinant of the given square matrix must not equal to 0. That is, determinant should not be equal to 0. So these are the two conditions. First, the matrix must be the square matrix. Square matrix means the number of rows and columns must be equal. Second is the determinant must not equal to 0. The determinant we have shown in the earlier videos how to find the determinant, and in the subsequent examples we will see how to find the determinant. Now the relationship is given by, that is, the given matrix multiplying this with the inverse gives us the identity matrix. Now an identity matrix is a matrix where there are only ones in the principal diagonal and zeros everywhere else, is equal to the A inverse multiplied with the given matrix. Now the identity matrix is like, if I have 1, 0, 0, 1, this is called the principal diagonal. The numbers, the elements on the principal that is principal diagonal must be only ones, and elsewhere must be 0. Like if I have another one, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a identity matrix here. That is, multiplying the given matrix by its inverse gives us the identity matrix, or multiplying an inverse by its by the given matrix gives us the identity matrix. Now how to find the inverse? Now the formula for finding inverse is, that is, inverse of a matrix is equal to 1 divided by the determinant of the given matrix multiplying this by adjoint of the matrix. So this is the formula for finding the inverse of the matrix. Now we will see an example. For that I have to rub this portion. So this inverse matrix or anything like this is used in mathematical economics. Now in the subsequent videos we will see the Cramer's rule, others input output problems. Now first concentrating on finding the inverse. Now let's take the marker. Now if I have an example like, first I will see whether it, now it is too much written here on this. Now it is okay here. Now if I have a matrix, let us say A is equal to 1, 0, 5, 2, 1, 6, 3, let us say it is 4 and 0. Now if it is a given matrix and I have to find the inverse of this matrix. Now first condition is that the given matrix must be a square matrix. Here this is a first condition is it should be square. it should be a square matrix, which is the case here because the number of rows are 3 and number of columns are 3. So the rows and the columns are equal here. Second condition is, so there it is 3 cross 3, number of rows are equal to number of columns first. Second condition is that the determinant of the given matrix must not equal to 1, that is, must not equal to 0, that is, determinant should not be equal to 0, implies it must be a non-singular matrix. That is, we can find inverse only to a non-singular matrix. Now here we can see, now the determinant here is given by, we take the first element, that is 1, and multiply it with the given determinant. We delete the row and the column in which it appears, this one, mentally, and multiply this determinant, that is here, that is 1 zeros are 0 minus 6 fours are, that is 24. Now this is minus sign which comes from the rule of the cofactors, which we have seen in the earlier videos. This is first is positive, negative, positive. Now here it is minus 2. Now this minus 2 row, delete the row and the column and take the determinant. Here it is 0 into 0, that is 0 zeros are 0, so I will write here 0 minus 5 fours are 20, so I will write here 20. Now plus this 3. Now delete mentally the row and the column in which the 3 appears, then we have this. Now the determinant here is 0 6 are 0 minus 5 1 are 5. Now solving this will give us, now here it is minus 24 times 1, that is minus 24. Now here minus 2 into minus 20 is plus 40, and here minus 5 times 3 is minus 15. Now minus 24 and minus 15, that is 5 plus 4, that is 9, and 2 plus 1 is 3, minus 39 plus 40, that is equal to 1. Here the determinant is equal to 1, that is, which is not equal to here 0, implies we can find the inverse, that is, we can find the inverse. Therefore inverse exists. Now to find the inverse, we form a cofactor matrix of this A. Now the cofactor matrix is, as we have seen, is given by, so I will repeat the rules here also. Now first element, we take the first element here, that is 1, and delete the row and the column in which appears, and take the determinant of the remaining elements. This will become the first cofactor, that is 1 4 6 0. So I will write 1 4 6 0. This is the first cofactor. Similarly, the first cofactor is positive, second is negative. Now second cofactor will be, now here it is 2, delete the row and the column in which appears, we get 0 5 4 0. So I will write 0, that is this, and this 0 5 4 0. So I will write here 0 5 4 0. Similarly, take the third element, delete the row and the corresponding column, we get 0 5 1 6, that is 0, but we have deleted this and this, 0 5 1 6. Similarly, take this element, delete the corresponding row and the column, we get 2 6 3 0. So here it is 2 6 3 0. Similarly, this one, delete the row and the column, we get 1 5 3 0. That is 1 5 3 0. Similarly, take this 4 and delete the row and the column in which it appears. This row and this column, we get 1 5 2 6. So here it is 1 5 2 6. Similarly, this 5, delete the row and the column, we get 2 1 3 4. So here is 2 1 3 4. Similarly, this 6, delete the row, the column, we get 1 0 3 4. So we get 1 0 3 4 here. Now the last one is 0. Now delete the row and the column, we get 1 0 2 1. That is 1 0 2 1 here. Now to check this out, to see whether I have done it properly, here I have some confusion. Here it is 5, I have deleted the row and the column, so here it is 2 1 3 4 2 1 3 4. Okay, all set up to this. This is the cofactor matrix. Now first is positive, second is negative, third is positive, fourth is negative. That is alternatively change the sign. Positive, this is negative, this is positive, this is negative. Now multiplying this, this is 1 zeros are 0 minus should I write it here, that is 0 minus 24. So we will get here minus 24. Here 0 5 4s are 20, that is minus 20, because sign is minus, that is minus 20. Similarly, 0 into 6 is 0, minus 5 1s are 5, that is minus 5. Here 2 zeros are 0, 6 3s are 18, that is minus 18, because of the given sign, minus 18. Similarly, 1 zeros are 0, minus 5 3s are 15, so 0 minus 15 is minus 15. Similarly, here we have 1 6 are 6, 6 minus 5 2s are 10, 6 minus 10 gives us 6 minus 10 gives us minus 4, but we have here positive, so this will become positive 4. Minus minus is plus. Here 2 4s are 8, minus 3 1s are 3, 8 minus 4, that is 5. Similarly, here 1 4s are 4, minus 3 zeros are 0, that is here minus 4. And here 1 zeros are 1 1s are 1, minus 2 zeros are 0, so we will get here 1. I hope the calculation is going right. Now this is C, implies C, this is the cofactor is minus 24, minus 20, minus 5, minus 18, minus 15, and 4, and 5, minus 4, and 1. Now adjoint is given. Now here we will see the transpose of this is C dash, means interchanging rows with columns. That is, row is interchanged with column. If it is here row, it will become column. So I will write minus 24, minus 20, and minus 5. And here minus 18, minus 15, 4, minus 18, minus 15, and 4. Similarly, 5 minus 4 1, 5 minus 4 and 1. So this is the transpose or the adjoint matrix. Now adjoint is given as ADJ. A is equal to the transpose of C, that is transpose which we got here, which is minus 24, minus 18, and 5, minus 20, minus 15, minus 4, minus 5, 4, and 1. Now the inverse is given by, we know what we are actually finding, that is a to the power minus, that means inverse is equal to the 1 divided by the determinant and a dj a. That is, the determinant is 1 divided by the determinant we got. The determinant we got, that is 1 here. Now multiply this with the adjoint which we got here, this matrix, that is minus 24, minus 18, 5, minus 20, minus 15, and minus 4, minus 5, 4, 1. So this will become now multiplying each element with the determinant. Here the determinant is 1, so this will become minus 24 divided by 1, that is minus 18 divided by 1, 5 divided by 1, similarly minus 20 divided by 1, minus 15 divided by 1, minus 4 divided by 1, similarly we have minus 5 divided by 1, 4 divided by 1, and 1 divided by 1. Because we are dividing here, the determinant was 1, so this will become this adjoint matrix also. If the determinant was 2, so this would have been 24 divided by 2, that is minus 12 here. But this is not the case. Here we are dividing with 1 because our determinant was 1. So this is minus 24, minus 18 and 5, minus 20, minus 15 and minus 4, minus 5, 4 and 1. Now to check whether we got the same, we got the result correctly, we have to multiply the given matrix by its inverse. If we got an identity matrix, then the result is correct. If not, then there is some mistake. So this is how the inverse is found. So I will repeat here. If A was given this, A is the given matrix. First of all, we have to check whether it is a square matrix. If it is a square matrix, then we can proceed to find the inverse. Since the number of rows and columns are equal, this is a square matrix. The second condition was that the determinant of the given matrix must not equal to 0. That is, determinant should not be equal to 0. That is, the given matrix must be non-singular matrix. A matrix where the determinant is non-zero is a non-singular matrix. Here both the conditions are satisfied because first it is square matrix. Similarly, determinant is 1 which is not equal to 0, so inverse exists. Now to find the inverse, we take the cofactor matrix of the given matrix. Now the cofactor matrix is formed by replacing each element of the given matrix by its cofactor. That is, if this is first element, we mentally delete the row and the column in which it appears and take the determinant of the remaining elements, which are here 1, 6, 4, 0. Similarly, we found all the cofactors here, and with that we give them the proper sign. First is positive, second is negative, positive, negative, positive, negative, positive, negative, and positive. Now this rule is given by, that is, to find the sign of the cofactor matrix in a matrix is given by the position of the matrix, that is A, I, J. To see the sign, we take this I and J, I plus J, we add the I and J and make it the exponent of the minus 1. Now if I have A31, now here A31 is this element, third row and first column. Now the sign here will be, then the sign of this element is given by minus 1 raised to this subscript, that is 3 plus 1, that is minus 1 raised to the power 4. Here it is, since it is even here, minus 1 raised to an even power gives us 1. That is, here the sign is positive. Similarly, if I have to find the sign of this element here of the cofactor matrix, then here it is at the position that is 3 2, that is third row and second column. So here the sign will be, that is A32 is equal to minus 1 raised power 3 plus 2, 3 plus 2, which is equal to minus 1 raised power 5. Now minus 1 raised to an odd power gives us the minus 1. Here we have seen the sign is minus. Similar is the case with every element. Now first we find the cofactor matrix. After that, which is after manipulating or solving this, we get this matrix. Now we take the transpose of the given cofactor matrix. Transpose of a matrix is interchanging the rows with the columns. Here the row, it is row, and this will become column. Now after that, the adjoint is given as the transpose of the cofactor matrix, which is this was the transpose matrix, transpose of the cofactor matrix. So this is the adjoint matrix. That is, adjoint matrix is the transpose of the cofactor matrix. Now inverse is given as 1 divided by the determinant multiplying this by the adjoint A. That is 1 divided by the determinant is here 1, and multiplying this with this adjoint A. Now after dividing, we got this minus 24, minus 18, 5, and so on. This is the method how to find the inverse of a matrix. I hope you got it, and if you really enjoy this video, please subscribe also to the Econ Maths channel. Thank you. Have a nice day.
So for more videos on mathematical economics, please subscribe our YouTube channel Econ Maths. Also comment, like and share. Thank you.